In a slide is moving from one slide to another. Do you see my screen now?
Yes, sir.
Okay. Now in full screen mode,
Yes, sir.
is the slides moving?
Yes, sir.
Okay, thank you. So today is the last topic of our first chapter. So we have seen different types of machine learning techniques, and today what we are going to see is about a topic called as representation or representations, in the sense that how you are going to represent your data. As I told you, machine learning needs the support of the past history of data for it to learn about something. So when we say that, we have a concept called as data representation or plainly representation. We will see what do you mean by that. Interestingly, when you take an application or you take some data for the machine to learn, those data are mostly in the form of a signal. It is in the form of an image or video or any complex data, as we have seen in the first class or the first session, right? So real-time world or real-time data is different. But when you want to give this data as input to the machine, a machine can't see, it cannot hear, or it cannot sense anything. But the only thing it knows is it can understand the number language, or it can deal only with numbers. So immediately you have a duty, right? You need to convert all the data in the real-time situation, right? In the real-time situation to a numerical form for the number to understand. This is where mathematics play a major role. Without mathematics, you cannot convert a real-time analog data into a numerical way. Right? Again, the problem is when we work with the data in the real world, it doesn't come to us nicely formatted numerical data. And it's going to be a chaotic data. You take a video will be there, you will have an image, below you can have a text, and then you will have the moving animation also. When you take a normal image, again, you will not know which is your region of interest or which is not your region of interest. So the data in the analog world or in the real world is also not that user friendly. When you have such a chaotic situation, how you are going to make the machine learn all those data? It may appear like a data, images, video signals. So the only thing you can do is you are going to do a alternate form of representation, right? Whatever data you have in the real-time situation, you cannot use that directly. You are going to represent the data in a different way, right? Maybe you would have, maybe most of you are doing mini projects now. If you have observed that when you are taking some application, maybe face recognition or something, it will be in the form of an image, but you cannot paste an image on a computer. Like, you have to write a model where the model is going to accept the numbers or something from the images. How do you do the transition between that specific data and numbers? That is called as representation. Again, when you say that I want to represent my data in the form of a number, you need to choose a number which uniquely represents the data. Right? You cannot say that I can give any sort of number. Any sort of number will not work. When you go for training a model, you must choose the unique characteristic features of an image. Say, for example, if you are looking at me, my face image will be recorded in your mind. All the way in which my head looks like, my nose, my mouth, ears, everything looks like, it will be stored within you. So later on, when you see me, or maybe when you come, maybe for a face-to-face session next year, in your final year, probably you may recognize. That's the way how a human being recognizes. Normally, you see a cat, a dog, whatever it may be. All the specific, unique characteristic features will be stored in your mind. That's why you get a problem in identifying the twins, right? When you are a twin, or when I am a professor and when I have two twin students in my class, I will have a great confusion in identifying who is who, because their face may look like. I am unable to extract the specific unique characteristic features from them, right? So it is not only converting it into a number. When you are converting it into a number, it should represent, that number should uniquely represent that specific data. Only then the machine can easily identify whether this is person A or B. So that unique characteristic stuff is called as features. So when you go practically into machine learning, maybe now mini project, when you go to major project, or every time when you work with ML, definitely this word features is going to always ring in your ears. Very, very important. Features are nothing but a numerical representation of a data, and that too specifically are crisply characterizing the unique nature of that specific data. But that should be taken from a heterogeneous data. You have video, you have images, signals, depends upon your specific application. So the definition for features are the reduced form of data. Right? When I say you have an image, when you have a number, the numbers will be mostly, the dimension will be lesser than your original image. This is another advantage of features. When you are going to train your machine, right? When you are going to train, say for example, I take an example among you. You are going to record my complete appearance. Maybe somebody is going to ask you later how Dr. Jude will look like, right? All my information is not necessary for you. You have some specific characteristic features and you describe to them, and then that person will easily identify. Right? So it is always going to be a reduced form of data rather than equal or even higher. Right? So 3 points you need to note down here. Features are the reduced form of data, dimensionality reduced information. The second point is it should uniquely characterize your data. The contents should be unique. And the third one is it should always maybe like something like user-friendly data, because the machine is going to understand only numbers. Maybe you can say plainly it is going to be in the form of numbers. So these are the 3 points which you have to always keep in your mind when you convert your data into numbers. So this process, this is what we are going to see today. This process of extracting features from raw data is called as feature engineering. So once you extract the features, then you can give us input. Now we are in this session, we are not going to look at the training or the learning or the process. The first step, how you are going to supply the data, how you are going to give the input data. That's what we are going to see today. So that process is called as feature engineering. Once you get a sufficient amount of features, you can give it to any supervised or unsupervised or whatever may be the learning. You can make the machine learn. But if your features are wrong, right? If your features are wrong, then whatever learning algorithm you use, there is high chance that it may go wrong. The final output may go wrong. So it says, it is a statistic says 75% of the ML engineers spend their time on data representation or the feature extraction process, because we do not know what will be an exact feature to differentiate my mobile phone and a laptop. Right? So there are huge, maybe a laptop and a mobile is something easy, but when you go for complex applications, when a machine has to do such things, how a machine can identify the unique characteristic features of a laptop and a mobile? Only then it can store those data and learn about a mobile and a laptop. So most of the time is spent on this feature extraction. In other words, we can say that feature extraction is extremely important in the process of making the machine learn. So as I told you, in traditional programming, the focus is on code, but now in machine learning, we are not going to call it as code, we are going to call it as models. And when you say models, when a model is suitable for face recognition, how can we improve the performance of the model? One way is we can change the training algorithm and all those things. Another way is they change the features. So the accuracy of the input data, when it increases, the chances of the machine learning the data or differentiating the data clearly also will increase. Right? So there are two ways. One way is, as we saw earlier, you can choose the best algorithm, whatever it may be, some hyperparameters tuning and all those things you can do. Absolutely fine. Another thing is you can also improve the model by adding more features and also changing the features. Right? So more amount of characterized data will definitely give you a better accuracy for your output system. So now we will see some simple methods. Maybe it will be useful for your mini project or project stuffs. I'm not going into the higher level of feature representation, but we will see a smaller or a representation for any beginners. You can look at this diagram, right? Can you see a diagram here? Yes?
Yes, sir.
Yeah, okay. So you can see here, I have a raw data, right? Say for example, there is a person who is going to sell the house, or you can take I'm going to sell my house, right? So I'm giving an ad in the newspaper or something like that. So I will normally say whether it is 2 BHK or 3 BHK and what is the internal features, where it is situated, on all those things, right? Now the machine should predict the price of my house. That is the application. The machine should, based on this information, it should predict the price of my house. But when I give this data, number of bedrooms, number of rooms, it cannot take the data directly. How can we do that? Right? So there are different types of data which you must understand. Right? This is the raw data, the one which I am. The left side of the figure one illustrates the raw data from an input data source. The right side illustrates the feature vector, how I have converted the number of rooms, everything into something equivalent to a number in the numerical form. Right? So this is called as feature engineering. This example is the best example for feature engineering, means transforming raw data into a feature vector. So many machine learning models must, or they require, I can say that they require the features to be represented as real number vectors. Real number vectors. It is always preferable to use a floating point integers also. Right? If you have at least one data represented as 9.3, then the other data should be represented only as 6.0 or 2.0. Suppose if you don't have any floating point numbers, then it is fine. 6, 1, 2, 3 is fine. But even if you have at least one floating point, because Python or MATLAB or whatever may be the programming code, it is going to represent your data only in the form of floating points. That's why a floating point representation is preferable. But again, it completely depends upon the user. Right now, we have some raw data. I have converted into a feature vector. We call it as vector because my data will have many inputs. Number of rooms is an input. Number of bedrooms is an input. Street name is an input. Number of basement rooms, everything is an input. So all these things should be specified clearly in the numerical form. So mostly in your practical application, your features, the inputs which you are going to supply to the machine is always in the form of a vector. Vector means what? More than one value. More than one value, which with each value corresponding to a specific concept in your input data. Now we will see how we are going to correlate or transform it into a number. The first one is, if your raw data is having a plain number, right? Say for example, number of rooms. Number of rooms is equal to 6. Then there is no problem for you in transforming that into a feature vector, right? When you have a real case number in your raw data, the same data can be taken for your feature also. But the only thing you need to do is represent it in the form of a floating point integer. It can be 4 decimal positions or 3 decimal positions. That is up to you. Right? So this is one of the easiest possible representation. The toughest possible representation is the categorical values. Say for example, here I have, say for example, the street name. I have a street name in my data. Street name, it is given as Shorebird Way. Right? This is a street name, but There may be many options. Say, for example, you are going to differentiate between a cat and a dog. Then you are going to give the cat image and also the dog image for the machine to learn. So when you convert these images into a number, how you are going to do that? That's where complexity arises. What number is going to be given for cat? What number is going to be given for dog? So that the machine is going to understand. Or in other words, if you take the street name example, we have many options, right? Shorebird Way, Dixon Road, Sirwani Road, Lincoln Road. Many roads can be there. Remember, I'm going to sell my house and the machine is going to predict the price of my house. When I have many options like this, maybe something like this, a pet. When I have an input data with a variable pet, which may have many options, unlike the previous case, number of rooms is equal to 6, it is fixed. Nobody is going to change. So it is very easy. Just go for 6. But when you have something in the English language, right, a pet or a color or something like a place, the rank in your class, who is going to take the first rank, who is going to have the second rank, who is going to have the third rank. Right? So these variables are going to have many options, which I am going to call it as categorical variables or categorical input data. Right? So when I see something like this is the most of the case. In most of your applications, you will see something like this. You want to differentiate the spam mail and the correct mail. How do you represent spam and how do you represent the correct mail? So this is where our complexity arises, and we need to have some solutions for converting these categorical values or English words to numbers. How can we do that? Right? So we can do that with the help of some encoding process. The simplest possible process is called as integer encoding. Right? Integer encoding. What do we do here? Plainly, each unique category is assigned an integer value. As simple as that. Right? So when I say dog, I will say 1. When I say cat, I will say 2. Right? For example, red is 1, green is 2, and blue is 3. Right? This procedure of encoding is called as label encoding or an integer encoding. The other name for integer encoding is label encoding, and it is easily reversible. When I give 1, we can post process and tell that it is red or green or something like blue. For some cases, it is enough. For some other cases, it's not enough, or it will not give you correct answers. Why? How? Right? Actually, when you give this number, this is the important point which you need to understand. When you give a number, right, 1 and 2, your machine is going to find some relationship between these numbers. Right? It will think, the machine is going to guess why cat is 1 or why dog is 2, or at least it is going to tell that if the difference between the two animals, if one is higher, then it is going to be dog, the other one it is going to be cat. So always your machine is going to draw or map some relationship between these numbers. In some cases it is not a big issue, but in some cases we will miss out the actual meaning. Say, for example, previously, the previous slide, we saw 4 examples: street name, your pet, your color, and the place. For the place or the ranking, it will not be a problem. Why? When I say person A first rank 1, person B 2, person 3 3, then is the first rank holder, second rank holder, third rank holder. So when the number keep on increasing, the machine will know he is not performing that much in the exams or whatever it may be. Right? So for the ranking, you can easily derive the solution or the relation by just giving the number. But what happens to the pet? Does giving a weightage of 1 differentiate a cat and a dog? I don't think so. What is the relation? What relation you will come to based on the variable, right? Or color, red, green, blue, 1, 2, 3, right? The machine will get confused. It will not be able to identify what exactly is the relation between these numbers. But for ranking, it is more easy for it to do, right? For categorical variables where no such relationship exists, such as our pet animal or our color or our street name, the integer encoding is not enough. Right? So rank, when the number exactly represents the relationship or when it is directly related with the variable, then it is fine. Otherwise, just giving 1, 2, 3, because normally the students make mistake here, right? So when they when they think that it should be converted into numbers, plainly they give some numbers and think that, okay, this is 5, this is 6. 5 means cat, 6 means dog. That is actually wrong. That is actually wrong. Maybe for that instance, it may work, but in the overall situation, it is going to, it is meaningless. So how can we do that? How can we do that? We have another procedure called as one-hot encoding. One-hot encoding. Integer encoding is very simple, only for the variables which has a direct relationship with that specific integer. If you don't have, you are going for a process called as one-hot encoding. So I will tell you why we should go for one-hot encoding. What happens when the real-time situation, when there is no relationship between the numbers and the names. Say, for example, the machine is going to predict the house prices. In other street name, you can take the example of a street name. The Shorebird Way, I am giving an integer value of 1. And Sirvani Road, I am giving an integer value of 2. Say, for example, right? There is no actual relationship between them. I have assigned randomly, but the computer may think, or the machine may think, or the model may think, when I give a higher weightage to Sirvani Road, the chances of the house in Sirvani is going to fetch you more price. Right? But is that true? No. A house, a better house in the Shorebird Way would have given a better price. There is no relationship, but the machine thinks in that way, and finally, when you sell the house in a Shorebird Way, it is going to tell you will get only so and so dollars, very less amount. But a house which is not worth enough in the Sirvani Road may fetch you more price. Again, you will be misled, and the complete system goes wrong, because the machine always try to find some relationship. So you need to be very careful what relation I am going to give when I give a number representation and the data representation, right? It is unlikely that there is a linear adjustment of price based on the street name, right? You should accept that. Just based on the street name, you cannot say that it is going to be good. It is based on the construction, it is based on the land, and the size of the land, and the number of rooms, and how they have constructed. All those things will come into consideration when we go for checking the price of a house, not just the street name. But if you give something like an integer encoding for the street name, your system will go wrong. So how can we avoid this problem? How can we do that? What you will do, what a human being will do. So when you check the house price, if 4 streets are given, right, you need to find the prices, or you must know the prices of all the 4 streets. Then you can come to a conclusion, okay, Sirvani Road is going to give you a higher price or a lower price. What I'm trying to say is the representation should include the data of all your categorical variables. If it is a color, even if you are giving for only red, the blue and green also should be there. Only then we can compare and say that this is high or this is low. Or in other words, we can say that our model needs the flexibility of learning different prices or whatever it may be for each street. For each street. How can you do that? This is the way how you can do that. When you go for representing red, don't just give red as 1. You indicate green and blue as 0, 0. Right? So you can look at this table. If you look at this table, you can easily identify. So when the machine looks at the first set of data, it will easily identify, I don't have a single street or a single color. I have 3 different colors. Then it will look for three different data. For 2 data, it is going to be 0. Only 1 data is going to have 1. That means that is going to get a higher priority in comparison to the other 2 variables. So when you go for green, what you should do? Again, you should not have the 1 in the same position. Right? Again, what do? You shift 1 position away from the first one. Maybe the second position. And you give red as 0 and blue as 0. Then it will check, okay, green is going to have the better price for this specific instant. In the same way, when you have a blue, you need to have 0, 0, 1. So this is the way how the data is represented. Data should be represented in the sense that I am not only dealing with one categorical variable at a time, I am going to deal with all categorical variables. Suppose this is only 3, but if you go for the street name, your data representation should be 1000, 0100, 4 bits should be there. When you go for such base, then the machine will understand, okay, when it looks at the data, okay, this is red, this is green, this is blue. It can easily identify instead of plainly giving 1, 2, and 3. So now you can see that the street name Shorebird Way is there. Previously in the number of rooms, I just went for only one value, right? 6.0 over. Your vector will have only one value. But here what happens? It is not a single value, but I'm going to include all my other street names also into consideration, right? So, but when I go for this specific data, I'm going to give Shorebird Way a higher priority, denoting that as 1 in any position. Any position you can give. Position doesn't matter, but the machine will know that the position changes. When it understands the position changes, it is going to easily differentiate between the data. Zeros in the other vectors. Now, one problem you can face in our one-hot encoding is you have 1 lakh. 1 lakh, I'm not sure, 10 lakhs or 1 lakhs, maybe 1 lakh. If you have 1 lakh different street names, right? What will be the size of your vector? Anyway, it is going to have only one, and everything else is going to be 0. Then your programming or coding will become too complex. Right? So there is another method, the third method, which is called as sparse representation. The same concept of one-hot encoding is represented in a simple way. How we do that? You create a binary vector of 1 lakh elements, right? But you are going to have only one data or a non-zero value alone will be stored in that matrix. All other things will be left out, right? You have 1 lakh vector size, and you know that there is going to be only one at a time, right? Which I'm going to call it as a non-zero value, and now I am going to store that non-zero value only. Now you may get a confusion. It may look like an integer encoding 1, but I am going to also indicate the position, right? I am also going to indicate the position. So the dense representation is the normal one, which we have seen so far. So many zeros will be there. I have given only 4 values. Many zeros will be there, and rarely you will have only one. But when you go for sparse representation, right, whether it is red, blue, or green, or dog, or whatever it may be, I am giving only one at a time, and also I am specifying the cell number. When I specify the cell number or the position, right, that means 1,40,395th position is 1. What do you mean by that? All the positions before 1,40,395 is going to have a value of only zeros. Right? The second one comes at 73,458. That means between these two, again, all are going to be 0. Right? Again, we come to the last one where again there is some 1, and again between these two, all things are going to be 0. This is only to save space. The concept remains the same. The concept of sparse representation is equivalent to the one-hot encoding, but the way in which you are going to store the data is different. Sparse representation is always helpful to store your data in a smaller space. Right? So these are some of the representations which you must know. Right? 3 things we saw today. One is called as the integer encoding, which is relatively simple, right? But it is applicable only when you go for something with a direct relation, something like a ranking or something, some position, first place, second place, third place. When you have a direct relationship between the variable and the number which you are going to use, then it's fine. You can give directly. A machine also will identify, okay, 1 is smaller, 2 is higher, 3 is much more higher. Then based on the ranking or marks, it can take a decision. That is called as integer encoding. But if you don't have a relation between your variable and a number, the second one comes into picture, one-hot encoding, where all the categorical variables weights should be there. When you give a weightage value of 0, that means it is not considered. At a time, that vector will have only one at a time. In the same way, all these data, if you have a sufficiently large variable, then you may not be able to represent all the data in the vector form. Then you can go for the sparse representation of data. So if you give like this, then there is a higher chance your machine will learn all the input data in a better way. So with this, your first chapter is over. You have learned about something about the supervised learning. You will learn something about the unsupervised learning. Then you had the concept of reinforcement learning. Then we saw about classification learning. Classification is part of a supervised learning. And finally, today we saw about the data representation. How can we represent the data? Answer your attendance. Amulya,
Yes, sir.
Judson,
Yes, sir.
Samyukta,
Present, sir.
Angel,
Present, sir.
Pawan, Abhinaya,
Yes, sir.
Kiran Kumar, Kiran Kumar, chat box. Kiran Kumar absent. Manideep, Banu Teja,
Yes, sir.
Jennifer,
Chat box.
Priyadarshini. Thanks, ma. Priyadarshini, chat box.
Yes, sir. Yes, sir.
Priyadarshini, okay. Afreed,
Present, sir.
Jayant,
Yes, sir.
Vikas,
Present, sir.
Paul Finney,
Present, sir.
Bhuvaneshwar,
Present, sir.
Sumant Kumar. Sumant Kumar.
Present, sir.
Okay, Ramesh Kumar,
Present, sir.
Neeraj Kumar,
Present, sir.
Sheikh Zubair,
Present, sir.
Dinesh,
Present, sir.
okay, Kirti, Batena Kirti, she's not there. Tejaswant,
Yes, sir.
Chandana Priya,
Present, sir.
Karthik,
Yes, sir.
Jay Kumar,
Yes, sir.
Soman Jay,
Yes, sir.
Janish,
Present, sir.
Vimal,
Yes, sir.
Harshavardhan,
Present, sir.
Uday,
Yes, sir.
Sakib,
Yes, sir.
Siddharth,
Yes, sir.
Praneeth,
Yes, sir.
Salomi,
Yes, sir.
Evinson,
Yes,
Alan,
sir.
Ronan, Kirti, okay, Kirti Prasanda, Ronan, okay, Sai Kiran,
Yes, sir.
Joshiba, chat box, no, Joshiba, Shiny,
Present, sir.
Yasmin,
Yes,
Abia,
Yes,
Jayasuriya,
Yes, sir.
Joanna Paul,
Yes, sir.
Manasa,
Yes, sir.
Ashrita,
Present, sir.
Narasimha Reddy,
Yes, sir.
Puneet Kumar,
Yes, sir.
Shiny,
Yes, sir.
Joshua,
Yes, sir.
Nagakiran,
Yes, sir.
Suraj,
Yes, sir.
Monica,
Yes, sir.
Taufik,
Yes, sir.
Manideep,
Yes, sir.
Dikshit,
Yes, sir.
Maria Angel,
Yes, sir.
Amrut,
Yes, sir.
Pavan Kalyan, Pavan Kalyan.
Present, sir. Present, sir.
Okay, Sainath,
Present, sir.
Gautam,
Present, sir.
Jagat Chandra, Jagat Chandra, absent. Vivekananda,
Yes, sir.
Shashank,
Yes, sir.
Sai Ganesh,
Yes, sir.
Gopichand,
Present, sir.
Ritvik,
Yes, sir.
Solomon,
Yes, sir.
Sudarshan,
Yes, sir.
Sujit,
Present, sir.
Suresh Kumar, Suresh Kumar, okay. Sunny,
Present, sir.
Amrita Das.
Present, sir.
Okay. So the absent is Jagat Chandra, then Joshiba, then Kiran Kumar. So these are the three absentees for our class. And tomorrow is also Monday timetable. I think we don't have class, and Monday also we don't have. From Tuesday onwards, you will be right taking up your exam. I request you to do well. I hope you will do well. Understand well, right? That is the first thing you must know. It is not all about getting the marks. Yeah, that is important. But more than that, how you are going to make use of these 3 months for your career. That's what you need to always concentrate on. Study, refer many blogs or the websites which is available in our internet. You will get lots and lots of information from that. Ask me doubts, right? You can feel free with me. You don't think that is a professor is there or my teacher is there. You don't need not have anything of that sort. Whenever you feel comfortable or whenever you find time, just post the question in WhatsApp or you can ask me. If I don't find a solution for that, I will refer and I'll come back to you and try to clear that. So do well, students. Thank you very much. And now you can leave the Google Meet.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, Pam.
Thank you, sir.
Thank you.